that's not a big deal. Okay, so I am on page 80 in your textbook if you wanted to follow along with me on the lipid pathway. Okay, so what we want to do is we want to be able to compare to what we had yesterday, okay? So do we have ATP? Do we have acetyl coenzyme A? Do we get everything at the bottom? Is there the citric acid cycle? And the answer to that is going to be yes, okay? So the first thing we need to do is break this lipid up into the building blocks, okay? And so we're going to end up with the glycerol portion, and we're going to end up with the 3 fatty acid portions over here. Now, what process does that? Hydrolysis. Okay, hydrolysis does that. Now, keep in mind, remember in lipids, we had CHOP, right? Correct? Would you agree? Everybody hear me okay?
Yeah.
Hello, hello. Okay, remember the P was standing for the phospholipid, but the majority of the rest were all CHOs. So remember that this could be rearranged to give us glucose, correct? So do you remember, so there's my candy from yesterday. In fact, I might even color it red like a peppermint. How about that? Okay. Where could I take glucose to, friends? What pathway? Could I jump over to here then?
Yes.
Yes, I could. I could totally jump over here and then go through that pathway. So do you remember, so I'm going to write 2-carb pathway. It's like a map. Go to the carb pathway. Remember the word assimilation back in chapter 1? See, I told you we were going to come back to chapter 1 again. In chapter 1, you can rearrange, okay, so that we're going to use those molecules, but you can arrange them into glucose. How would they be arranged? Probably enzymes, okay? No energy though so far. Okay, so how are we going to take these fatty acids and actually get them into the citric acid pathway? So I'm kind of modeling what we see in your textbook. So I'm drawing 2 arrows like this. Okay, now keep in mind, if you don't need this fatty acid, what are you going to store this as? You're going to store it as fat, aren't you? Those love handles. I'm going to draw on my favorite baking tool, Crisco. You know what Crisco is? It's what makes cookies taste delicious. It's the modern version of lard, okay? This is why I bet you that Zender's Bavarian Inn all use lard still in their baking because it makes things delicious. But instead of using butter and your cookies being flatter than a pancake, you can use Crisco instead. Okay, if you do need to metabolize those fatty acids, which are filled with carbons and hydrogens and things like that, you can break those down, okay, through a series. Now, when you convert, and what we're going to do is we're going to get both of these to become acetyl coenzyme A. Have you heard of acetyl coenzyme A? Well, sure, we talked about that yesterday, right? So I'm going to draw my carrot from yesterday. But how do we get to that part? Because you know what? This isn't the same. This isn't the same as breaking down and getting pyruvic acid. We have to go through a process called beta oxidation, okay, which is a little bit different. And when we metabolize fats, we also get a byproduct of ketones bodies. I don't know what I'm drawing. I was drawing a toilet. And then I'm drawing fruit. And I'll tell you why. Have you ever heard of someone going on the Atkins diet and having fruity smelling urine or their breath being fruity? Have you ever heard of that? Okay, so let me read to you from the textbook what I'm talking about. It says a fat molecule must first undergo hydrolysis before it can release energy. Okay. Upon hydrolysis, some of the resulting fatty acid portions can react to form molecules of acetyl coenzyme A by a series of reactions called beta oxidation. So that's as far as we're going to get into the detail. Excess acetyl coenzyme A can be converted into compounds called ketone bodies. Okay, and one of those ketone bodies, such as the chemical acetone, may be later changed back to acetyl coenzyme A. When you metabolize fat very, very quickly, okay, you get these excess amount of ketone bodies. That's great. It's a reserve amount. Here's the thing, though, that they can be released in the body through your breath or through your urine. Okay? Now, if you're metabolizing fat because you're on the Atkins diet and it's a high protein diet, and in the high protein diet, you are metabolizing fat, like, or if you were fasting, okay, you would release a lot of ketones. That's great. The problem that you have to really watch is if those are not being eliminated, okay, if it fasts to lose weight, sometimes you can actually develop a serious pH balance. And actually, so this is ketone acidosis. Have you heard of acidosis? Have we studied that?
Yeah.
Yeah. So acetone, friends, is nail polish remover. Okay, do you know the smell of nail polish remover? Yes? It's a pretty strong smell, isn't it? So imagine your breath would smell like that, your urine would smell like that. Sometimes those that have diabetes can go through and go into acidosis. And that usually is, you got to really watch. They call it the ketones. So I had a student who ketoacidosis ended up in the hospital a lot. Because she was having a hard time regulating her diabetes, and that pH, her blood pH went down too low, and then things don't work so well anymore. So notice that it's not a direct path, is it? It's not like glucose right to acetyl coenzyme A. You have to do some manipulating, and you could end up with some waste products, these ketone bodies. So not as efficient, okay, as necessarily the glucose, but you can get glucose. but it takes a little bit longer, which is why fat is not one of the first ones to be broken down. Now, this acetyl coenzyme A can then join. All right, here we go. Citric acid cycle. Draw your orange. And as long as we're talking about, the citric acid cycle, you're still going to get the same things. You're still going to get, are we going to get ATP 36? Yes, yes we are. Are you still going to get a byproduct of heat? Yep. What was our gas that was given off, friends?
CO2.
CO2, thank you. What was our liquid that was given off?
H2O.
H2O. See how we're getting the same thing? We're just not getting, it's like doing a map quest and not doing the direct route, but going on the scenic drive. How about that? Okay, only because that we're made up of some different molecules. So when it talks about the series of reactions, it's called beta oxidation. And I've looked it up and it's very complicated, but, and I'm sure it does cost the body some energy to have it do that. But it's not a direct path, okay? But can you gain weight? Can you gain weight from having too much fat?
Yes.
Yes. Go back to your carbohydrate pathway. If we don't break this down and go into, can we store this? Can we store glucose? Oh, where do we store glucose? We talked about this, chapter 1. What organ?
Is that the pancreas?
Careful. The pancreas is a great one to, the pancreas, you were on the right track, George. The pancreas liked to talk to?
The liver?
The liver. There you go. Good job, George. You got us started. To the liver. Yep. And remember, you can still store it as fat. Can you get too fat? Can you get or gain weight from eating too many carbs? Sad face. Yes, right? All right. So here we go. Last one. Proteins. Broken up by hydrolysis into an amino acid, okay? Into the building blocks, the amino acid, okay? And the portion, so remember, this is CHO, this is trans, isn't it? Okay, this is trans. So we have the amino portion, and then there's the nitrogen portion. They call it the deaminated portions. Of molecules, and then you have the NH2 groups, okay? So let me go back and show you real quick, okay? So like we're talking about, so all those amino acids, like on the amino acid wheel of fun, so they're very complex as far as the different groups, okay? So the amino acid has an amino group on one end and a carboxyl group on the other. So the carboxyl group would be the deaminated portions that we talked about it, where the NH2 group would be the other piece, okay? So I wanted you to know there's more to that. I'm gonna put carbon, the carbon part. How about that? the carboxyl group and the NH2 group. Now the NH2 group, that gets released, okay, that's a waste. There's nothing we can do with this. It's excreted, okay? In a type of material, we call it urea, which is actually excreted in your urine, okay? So to break up that amino acid, okay, we call this process deamination, which means breaking up the amino acid. So it's a type of digestion, okay? Just like we had beta oxidation, this piece we have deamination. So it's going to take a process to get these pieces. The carboxyl group is going to have some carbons, oxygen, hydrogen. So why don't I just put, it's going to have some CHO here, okay? Now this can go ahead and go on to the carb cycle, because this can be converted into our candy. Okay? If you don't use it, you store it. So it can be stored as a fat for later. Or we can go ahead and use that deaminated portion, that carboxyl group, to make acetyl coenzyme A. And then, friends, it's just the same thing all over again. Okay, remember I'm drawing a caret because of the acetyl coenzyme, that coenzyme A. And then we go right into the citric acid cycle. All right, guess what? We're still getting energy. Oh, how would I spell energy right? 36 ATP. We still get what am I drawing? Nobody could see. What am I drawing?
Heat.
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 Unfortunately, that's just a byproduct, right? Well, what happens when you exercise?
You get hot.
Hot, that's right. You release heat. Unfortunately, that's a waste product, isn't it? You can't harness that. I don't know what you would do to harness that. Carbon dioxide and water. So if you ever hear of in the exercise, you know, like you're burning calories, man, you technically are, but you're breaking down that glucose, okay? And you're not burning necessarily. You are releasing heat, but we're releasing the ATP. Now, when you're exercising, that ATP goes to muscles, okay? And later on in the muscle chapter, okay, has anyone ever exercised and then become really super sore after it?